Hi kids, it's Dr. Runs here with your lesson for section 4.4, the slope of a line. This is a really important lesson, so I hope if you were unclear on it in class that you are coming back to get a rewatch, to get some clarification, another round, and hopefully you'll catch more of the details and get a more fuller understanding of what we are doing right now. Just a disclaimer before we get started, this is just the high points of the lesson, however. It's not a perfect lesson. It's not the most exciting lesson in the whole world, but it is something to help my kids at home, and we'll get you going on your homework and also give you some contact information if you still need a little support. So this is the beginning of our lesson. Slope is a really exciting concept. And it is referred to in a variety of different ways because it's used in a variety of different contexts. So you will see it represented sometimes as the difference in y. That's the up and down movement on a graph over the difference in x. Sometimes you'll see it as this equation, y2 minus y1 over x2 minus x1. Some math teachers will use the slang rise over run, and sometimes I'll say it's the up and down over the left and right. But the textbook definition for the slope, it's the number of units a line rises or falls for each horizontal unit of change. Another way to think of it is it's the number that's assigned to a line to tell how steep it is. Slope is represented by the letter M. Sometimes in class we joke by saying slope, until we get that down solidly, that M represents slope. And so we talked about some ways that you may have seen slope in practical places out and about. We talked about ski slopes and the pitch of a roof, really interesting standardized things that contractors can use for, say, a roof or an access ramp. We talked about how you could see these when you are traveling in the mountains and how slope is used to keep drivers safe. Told a funny story about my friend Steve, but we won't put that here. That's kind of more of a bonus feature for class attendance. Okay, so here is page 2. We are going to find the slope of a line that passes through these 2 points, 5, 2, and 3, 4. And this should say 10, 4. I apologize. I've made that correction on my other copies, just not the one I'm talking from. 5, 2, and 10, 4. And so they are labeled here. And so I will recommend that you start these by labeling until you get very comfortable with what you're doing. So remember, a coordinate is made up of an x and a y. And we will use a small 1 after that x and y to indicate the first point, and a small 2 after that x and y to indicate the second point. And remember from the previous page that the equation to find slope is slope equals y2 minus y1 over x2 minus x1. And now all we are going to do is substitute the values that are in the corresponding position into the equation. So I'm going to rewrite basically the same equation, but instead of the label for the position in the point, we are going to use the number that is there. So here is y2, so 4 is in that place. And I'll put it in parentheses to show that I substituted that in from another location. So minus y1. y1 is 2. Over x2, which is 10, minus an x1 is 5. Now from here, we can just simplify. 4 minus 2 is 2. 10 minus 5 is 5. The slope of a line that travels from or through those 2 points is 2/5. I don't have a straight edge, so I did exactly what I tell my students, to be creative and find one. So I found my grading scale thingy. I don't know what it's called. Okay, so what that means is if I follow this line, it will rise or fall 2 units for every 5 units of horizontal change. That sounds confusing until we go back to the graph to show what that really means. So if it rises or falls 2 units, let's say I'm traveling from here to here. Rises 2, for every 5 units of change. 1, 2, 3, 4, 5. Isn't that neat? I can do it with other points too. Here's one here. 1, 2, 1, 2, 3, 4, 5. I can even do it between 2 points that are far away from each other. See, if I go from this one to this one, I would have to go 1, 2, 3, 4 over 10. And 4 over 10 simplified is 2/5. Isn't that cool? Slope is a really neat thing. Okay, let's try another one. We're going to do the same exact process, actually 3 times. And so before I start talking through this, I really recommend that you pause this and try to go ahead of me, and then simply use this video to check yourself after you have done the work. I will make a small correction though. Every so often there's a typo, and again, these are fixed in my student notes, but it just didn't make it on here. And I think that should be accurate now. So please go ahead of me, see what you can do. You may not be able to do it all perfectly, but do a little and then hit play again. Okay, so what I will do here is x1, y1, x2, y2. And I will rewrite the equation again because I am a good student and I want to commit this to memory. And the more I practice it, the faster I'll learn it. And now, here's y2, and that's 8 minus y1 is 2 over. Here's x2, which is 9, minus x1, which is 1. Now we can simplify. 8 minus 2 is 6, 9 minus 1 is 8. And this simplifies down to 3/4. So if I were graphing this, for every 1, 2, 3, I would go up. I'd go 1, 2, 3, 4 to the right. So my slope would be about that. All right, let's try another one. Again, feel free to go ahead of me. Push pause and then push start again. See what you can do on your own. It's good to challenge your brain to think independently. Okay, so we're going to find slope. The number in the y2 position is 5 minus the number in the y1 position is -3. I believe here you'll see why it's so important to put the numbers that we substituted in parentheses. I'll go back in a second and explain that in greater detail. x2 is -2 minus x1. Now, in case these two negatives confuse you, let me please show you one thing. This negative here came from this negative here. That negative is from the equation to find slope. This negative here comes from this negative from the point. And so when your x1 or y1, when either of these numbers is negative, that creates a double negative or a positive. 2 negatives are positive. And so we actually will add. 5 and 3 make 8. 2 minus 6 is, -2 minus 6 is -8. Anything over itself is 1. And of course this one is negative. The slope of this line is -1. Later in life, you will see how to graph this, but it would look like this. You're going to have to take my word for it for now. But we are going to get into that in the future. There's so many subtle things about slope and what it means and what it looks like graphing, and I can't possibly put it all in one lesson, so sometimes I just have to leave you on a cliffhanger. Okay, I'm going to teach this next section from my teacher copy because it's color-coded, and so it will help a little bit. This says Roans's rules about writing number slope. However, these are going to be rules for future teachers too, that are confusing until you've had a lot of practice with them. So I recommend that you keep this as a reference moving forward. And we'll work on it in class, of course. Keep your slope in a simplified form. So if you have 3/6, please simplify that down to 1/2. Do not use decimals. When we use slope for graphing, decimals won't help you. Also, keep the improper fractions improper. So for example, if I have 10 over 6, that can be simplified, like what we said in the previous rule, down to 5 over 3, but don't turn it into 1 2/3. Again, when we go to graph this, which you haven't done yet, so some of these rules are kind of confusing because you don't have a lot of context for them. But when you go to graph it, this won't help you. This will. So don't turn it into a mixed number. Other subtle things, anything over 1 is itself, so you can simplify that down to 4. Anything over itself is 1, so you don't have to keep it like that. Just turn it into a 1. 0 divided by anything is 0. Anything divided by 0 is undefined. Sometimes we say a 0 under the fraction bar is undefined. And we talked about what that meant in greater detail. And I can actually, that's a good segue, show you what that means. An undefined line is like these purple lines here. This one and this one. These two are undefined. They run vertical. The opposite of that is a slope of 0. That's the yellow lines. Those are a horizontal line. That kind of makes sense. There is no slope to this line because it's a flat line. We think of slopes like, I don't know, like a ski slope, right? A ski slope with no slant to it, with no depth to it, would just be flat ground. There would be no slope, or the number for nothing is 0. Another couple things that we pointed out here. These green lines have both positive slope, 2 and 1/2. They both go in this direction. Or if you look at the red lines, -5 and -1/5, they both go in this direction. Another thing that we observed is that slopes with a fraction tend to be less steep than slopes with a higher number. So this 5 is very steep. The slope of 1 is not so steep. The slope of 1/2 is even shallower, and the smaller slope of 1/5 is even shallower still. And 0 again has no slope at all. We see a slope of 1 and a slope of -1. Those are the ones that go through the corners of the grid lines as we move across the coordinate plane. This would mean up 1, right 1. So up 1, right 1, up 1, right 1, up 1, right 1. And then the opposite for -1. Again, this is just an overview. Of course, we are going to dissect the heck out of this as we move forward. Okay, and then, of course, we said the greater the slope, the steeper the line, which I demonstrated to you. This is Mr. Slope Guy. He helps remind us of some important things while we are going through this learning process. Again, I keep saying this, you will get a much richer, deeper understanding of this as we go. But for now, again, this is just an overview. Mr. Slope Guy helps us remember that a positive slope will go this direction, a negative slope will go in this direction. Undefined is a vertical line, so there's a U for undefined, and a horizontal line has a slope of 0. He's helpful and kind of creepy, but that is to help you kind of get you by until we start diving into those things. Okay, one thing though that I do want to go deeper into is how you can find parts of coordinates when you are given the slope of a line. So here we have an example. I have a slope of 2/3. So this line goes up 2, right through 3, up 2, right 3, as it crosses the coordinate plane. And it goes through these points, -1 and 1, 4 and something. And we don't have a graph that we can use to look at. So how can we figure this out? So what you can do is substitute still, like what we did when we found slope, the parts of this equation with what have been given to us. So slope is 2/3. I'm going to put it in parentheses to show that I'm subbing it in from somewhere else. Equals, and remember we have x and y, 1s and 2s. So when we do that, we can see we know all the parts of this equation except for just the y2 part. So I'm going to do question mark, we don't know, minus y1 over x2 is 4 minus, and there's the x1. Okay, so now this is what we're going for here. And it's just a process of seeing what we can simplify, take it one step at a time. This isn't something that we're going to solve just automatically in one little step here. I see here two negatives and they create a positive. I'm going to simplify that part first. So 2/3 is something minus 1 over 4 plus 2. Well, there's something I can simplify there too. 4 plus 2 is 6. 2/3 is something minus 1 over 6. Well, if you'll recall from our previous lesson, we can eliminate that pretty simply by multiplying by the reciprocal, or multiplying by what's in the denominator is the shortcut of it, because 6 over 6 is 1. And so those would cancel out. And what I do on one side, I do to the other. So 6 times 2 is 12 over 3 is something minus 1. Well, what's 12 over 3? 12 over 3 is 4. 4 is something minus 1. I'm out of space. Foof. I'm going to continue right here. My fat markers. Something minus 1. We can just solve this like a normal equation, right? If we were solving an equation, this would be an x. That gets confusing because there's x's and y's in here. So we're just going to treat that like a variable. To isolate that, the reverse of a -1 is a +1. What I do on one side, I do to the other. 4 and 1 is 5. 5 is my mystery number. Now, how do I know? I can plug it back in or sub it back in. We can plug it back in to check our slope. So if we do that, here's the work that we did. We said it was 5. So if I pretend that I don't know the slope, pretend I don't know that, and that this place is filled with a 5, it would be 5 minus 1 over 4 minus -2. And when I sub that in, 5 minus 1 is 4. 4 plus 2 is 6. And then I got 2/3, which is what my slope should be. It works. It's a very validating feeling to put that in and find that it actually works out. Okay, you will, so let's try another one. Again, I encourage you to push pause on this, see what you can do. You may not be able to do all of it, and that's totally fine. You've only seen one example of this in your whole life. But challenge your little brains to, you have enormous brains that are very powerful. Challenge your brains to do as much as you possibly can, and then I will walk you through the rest. Okay, remember that this is x and y, x and y. Here are the 1s, here are the 2s, and there's your slope and your equation again. So now instead, I'm going to write 1 is 4 minus, I don't know, I'm just going to keep it as a y. It's the y1 really. Over 3 was in the x2 place and 1 is in the x1 place. All right, 1 equals 4 minus y. 3 minus 1 is 2. And we can eliminate that 2 by multiplying each side by 2. 2 over 2 is 1. What I do on one side, I do to the other. 2 is 4 minus y. We want to get this y by itself. It's with a +4. The reverse of a +4 is a -4. Again, what I do on one side, I do to the other. -2 equals, be careful, bring down a -y. And to make this positive, we'll multiply each side by a -1. Or another way of saying that is I can just flip this sign as long as I flip the sign on the other side. That'd be like multiplying -2 by -1 to get 2. Okay, so my suggestion is that y equals 2. And how do I know? I know by checking my work. And so, again, I can pretend that I don't know what the slope is. We were told that the slope is 1, but we can instead, if we think that this is 2, we can put it in as if we knew it. So y2 minus y1, so 4 minus 2 over 3 minus 1. 4 minus 2 is 2. 3 minus 1 is 2. 2 over 2 is 1. And it worked. So I can have confidence that my solution is correct. Okay, that's a tough lesson. I'm not even going to sugarcoat it. That's just a tough lesson. And so I do believe strongly that by participating in the practice, you will firm up those skills quite a lot. And so for 1, 2, and 3, you were to tell if that's a positive, negative, 0, or undefined line. So for example, like this one, you might need to use Mr. Slope Guy. Remember him? So a line that goes in this direction, like this, would be a negative slope. Let me just write a little negative sign. I'll let you do the next two. Okay, for this section here, it says plot the points and draw a line through them without calculating. State whether the slope of the line is positive, negative, 0, or undefined. You are welcome to complete these however you are most comfortable. Some people do not need to plot the points. They can do this mentally. I will talk you through once, and if it helps, great, and if not, you should actually plot these points. So some people can say, okay, so suppose this is point 2,4, and say I want to travel from 2,4 to 5,2. Well, I'm going to look at the x values first. This is the horizontal movement. If I'm going from 2 to 5, I'm going to be moving to the right. And then if I'm looking at the y values, the vertical movement, if this is 4 and then I'm going down to 2, I'm going to go down. So those would be my 2 points, which create a negative slope. If you follow that, if that made sense to you, if you're kind of a spatial thinker like that, you do not have to plot these points on a literal coordinate plane. If that made no sense to you, and I would be one of one of your kind, that is a little bit abstract. And if you would rather plot the points and create a little graph like this to tell if it's a positive, negative, 0, or undefined slope, you absolutely can do that. Now, it does say without calculating, but once you have found your answer, you are welcome to calculate to check your work. But please don't rely on that to find your solution, right? Okay. For this section here, you are finding the slope of a line going through the 2 points. So you will use m equals y2 minus y1 over x2 minus x1. I recommend that you use lined paper. I recommend that you actually label your points and show all of the steps until you're feeling very, very comfortable with that. I also want to refer you to the Rones's rules or the math teacher's rules so that you are not stopped up by subtle little rules. So remember to simplify your slope when applicable, but not to the point where it's a mixed number. Remember that 0 in the numerator is 0, 0 in the denominator is undefined. Anything over 1 is itself, anything over itself is 1. Okay. And then for 25 through 33, that's just like what we did in the end of our notes, where we're finding the missing piece of these coordinates. And I want to recommend that you check your work when you are done. Supposing that you don't know slope when you're checking your work, to see if when you substitute that value in, if it comes out correctly. And this is finally one more section that we have not talked about yet in our notes, but is fairly straightforward. So this is asking if I have these 2 points graphed in a coordinate plane, where in this coordinate plane, x represents minutes and miles, okay, where you can track how many miles a person or a car or whatever can travel per minute, right? And you're trying to find the slope. Once you've calculated that, so this would be, for example, 15 minus 10 over 6 minus 4 to get 15 minus 10 is 5. 2, okay? So this would be a slope of 5 over 2. Or you could say 5 miles, because y is in the numerator. You can travel 5 miles in 2 minutes. That's quick. And so you can write your answer, squeeze it in there, 5 miles in 2 minutes. Or if you would like to, you can number on the bottom and write your answers bigger there. Okay, you don't have to, this is not unit rate, so you do not have to simplify to get a 1 in the denominator. Okay, so you're finding slope and then putting a label in there too. Okay, guys, this is a tough thing, and it's going to take a lot of practice, and it might be that you have to fix it up at the end too. This is a learning process. We're not always going to get it perfect the first time. If you need help, I'm always happy to help you. Shoot me an email, and Mrs. Rones, get me started on this, or is what I'm doing right, or I understand this part but not the other. Let me know, and I will get back to you as quick as I can. Thanks a whole lot for watching, and I will see you in class. Bye.